and these are the some questions which is very important. And first question we have, what are the solid principle and what is the difference between the solid principle and design pattern? So first of all, we have to know what is the solid abbreviation means. As a S representing the single responsibility principle, O representing the open close principle, L representing the list substitution principle, and I interface segregation principle, and D is dependency inversion principle. And this concept have to be known very clearly, very clearly, because modifying a question from this concept nowadays interviewer was asking, and asking also I also face the same type of question, so I can also discuss that one. Solid design principle and difference in the design pattern we have to know. So solid principle is a set of principles which must be followed to develop flexible, maintainable and scalable software system, and it is not concrete or abstract, I can say, but in the design pattern it is a concrete and solve a particular kind of problem in the softwares. Like we have a different design pattern, like creational design pattern, structural design pattern, behavioral design pattern. In the creational we have again three categories: factory pattern, object pool pattern, singleton pattern. Singleton pattern is the most famous and everybody is aware about that. Every monolithic architecture or some other, like you are using architecture, most of the application using this singleton pattern. And second, we have a structural design pattern. In this we have adapter pattern, decorator pattern, composite pattern, and similarly for the behavioral we have a chain of responsibility pattern, mediator pattern, and observer pattern. So design pattern are concrete and solve a particular kind of problem in a specific and fixed manner, but in the solid that is not. And we have to be now discuss each and every principle in the solid one, I can say. As a solid representing a single responsibility principle, it means it have to be changed for a single region. As you see in the code, we have a class employee and there is a one method calculate salary, and there is second method we have get department, and third we have a save. So what we can see, we can create one other method for the save purpose. Not other method, I can say some other classes which implementing the save method, because the save is a common for all the stuff. So why we can add extra function over here? We can create some other class which executing or which implementing the save function. So what we can do, we created some other class, like example in the class employee repository. In this we are creating the save method which is only saving the all types of mechanism, all types of request what you are trying to save over there. So in the diagram, in the code also you can see, and in the picture also we have, for the example, like we have invoice class, and we have there are different request, I can say add invoice, delete invoice, sending email, error logging. So I can see the sending email and error logging is extra responsibility which we can't include in a single class, but add invoice, delete invoice, similar type of thing. So we can create these two methods in a one class, and for the sending email for the other class, and error handling another class. So this we can separate, and when we have a use a requirement, we can access or we can inject with the help of DI and use it. So this is like violating the SRP principle, and SRP principle state that like we have to be single region to change, not extra space, extra method or extra functionality we have to be add in the single class. Next we have a open close principle. It means like software including the like classes, modules, entity should be open for the extension, closed for the modification. And for the example, we have a class account, there is a different member like name, address, balance, and one method is like calculate the interest. And in the interest you can see we have an account type. In the account type we have a saving. In the future we have some like current account, saving account, FD account. So we can't do every time like modification account type, some saving or current. We can extend the method that will follow or that will allow in the open close principle. So I can see inserting one more else if will be a problem, and open close principle because you are modifying the class rather than extending, because again else if it will become complex or not good practice. So that's why we can create another one which is extending the method, and that will follow or that will execute our open close principle. So you can see we have account class, name, address, balance, and I created the one like we have a interface I account interfaces which we have a method calculate interest, and this method we are implementing in another like different account. We have a saving account, other account, or current account. We are inheriting I account, extending the I account, and implementing calling the interest what we are applying over there for the saving or for the other one. So this is a good practice for the open close principle wise and applying in our project in our application. So the benefit of it is like I can say simple testing required to test the individual classes, but if you like to keep and adding and modifying the one classes, then even for the smaller modification, the whole class need to be tested. Sorry. Now, next we have a list of substitution principle. In this principle, it states that the object of child class must be able to replace an object of the parent class without the breaking the application. As we have an example of the employee. Employee is a base class, and employee have a two types of employee: permanent employee, contract employee. And you can see these two types of employee have a different facility in our organization. Permanent employee gets some other benefit. Contractual employee gets some other benefit which is not as compared to same as a permanent employee. So basis on that we have some method over implementation, and you can see we have calculated salary for both of them, and calculated bonus is not applicable for the contractual employee. So you can see we are writing the same method we are not implementing in the contractual employee. Public override intent calculate bonus, and we are throwing the error throw new not implemented exception. Next we have an interface segregation principle. This means like a class should not be forced to implement the interface that it does not use. It means we don't have to create every time generic interface. Sometimes some class want to implement some specific method, some class sometime not. So if they are using a generic one, then they have to be implement what they are not want to implement that method. I can say, like in the example you can see we have a public interface iVehicle is a two method driver and fly. I have a class flying car, I have a class car. In the flying car we are inheriting the iVehicle and implementing the drive and fly, but in the car I want to implement only the drive, not with the fly. So why we can why we can use them. So interface segregation principle state that what is the require as per the user requirement, as per the client requirement, create that interface only, not extra one. You can see again I implemented the interface with the help of drive, and with the fly I drive, both are different. Yeah, and again we have a different classes, car and flying car. Flying car need to implement both drive and fly, but car implement only drive method or drive class. So it will only inherit the drive one, not for the flying one. So it is better to have multiple smaller interfaces than the larger interfaces, which is not used. Last, we have a dependency inversion principle, and it means like high level class must not depend upon the lower level class. As example, you can see we have a class data access layer, and we having a add customer method. And inside that you can see we have a logger, and with the help of logger we are logging the name or date what we want. And this logger is coming from this class file logger, and there is a method is implemented the log. So you can see this data access layer have to be implement the log method, but it is dependent on the file logger class. If this is not in that, then it will not get the access over there. We have to break this solution or break this problem and have to apply the dependency inversion concept over there. What we can do, we can create the different interface for this iLogger, and this iLogger have a log method, and this log method implemented in the file logger classes, as you can see here. And coming to the data access layer, we can directly use this iLogger as a data member, and injecting in our constructor. With the help of constructor, we can directly access this logger mechanism with the log method. So it is not depending on the lower class. I can say not depend on the add customer one. And after this solid principle completed, we have one principle, like I can say dry principle, and it means like don't repeat yourself and don't write the same functionality multiple times. Because of this we are using the oops concept. We create once and use or reuse multiple time whenever we have a requirement. And this is most of the time you can see dependency injection property or features is implemented for helping this type of principle. Instead, write code once and then use it at multiple places using the inheritance. Or right now in the .NET Core, a modern coding framework, you can say as a dependency injection. That's it about the